when you multiply numbers together, it doesn't matter the order in which you multiply them. For example, whether you do 8 times 6 or you do 6 times 8, it's still 48. So 8 times 6 is equal to 6 times 8 is equal to 48. The same is true if they were not single-digit numbers. It doesn't matter. So, for example, if you did 43 times 17, you can do it as 43 multiplied by 17, or you could do it as 17 multiplied by 43. And the answer will come out the same. You can try it for yourself if you want to prove it. But the same does not apply when you're dividing. When you're dividing, if I say to you 10 divided by 5, or if I say 5 divided by 10, they are not the same. So whereas with multiplication, you can switch the numbers around and it doesn't make any difference to the product, you cannot do that with division. So it's very important you say it the right way around and you do it the right way around. This says 10 divided by 5. This says 5 divided by 10. Well, let's look at the result of each one. 10 divided by 5 means how many 5s go into 10? Well, the answer is 2. 2 5s go into 10. So 10 divided by 5 equals 2. But if it's 5 divided by 10, then the question is how many 10s go into 5? And the answer to that is only half. You cannot fit a whole 10 into a 5. So when you divide a smaller number by a bigger number, the answer is going to be less than 1, because the bigger number will not fit a whole once into the smaller number. So really important that you always divide the first number by the second number and not the other way around. So now let's look at the method for division. And again, as with multiplication, there's long and there's short. I will demonstrate both, and I recommend the short for the same reasons. It's quicker and it takes up less space. It's more efficient. So let me now demonstrate a method for doing a division that you wouldn't normally do mentally. Supposing you had a number such as this, 7,356 divided by 8. Well, first of all, be careful. It's 7,356 divided by 8. In other words, how many 8s will go into 7,356? Don't get it back to front because it will matter. So to help you, to make sure that you actually write it the right way around, the tip is always put what I call a roof over the first number. Regardless which number is bigger, which number is smaller, which number is whole, which number is decimal, you always put the roof over the first number. And what I mean by the roof is when you do division, you write it like this. And this L shape I'm calling a roof for convenience. So the roof always goes over the first number. And then it's the second number, the one after the division sign, goes in front of the roof. And then to divide this number by the 8, you divide 8 into this number one column at a time, starting with the most valuable column, which in this case is the thousands column, which contains a 7. And this is how you do it. You say 8 into 8 into 7 will not go. One column at a time. 8 into 7 will not go, because 8 is bigger than 7. So you can't fit any 8s into a 7. That's useful because it means that the 0 must go here to show that the thousands column of the answer is empty, i.e. there are no thousands in the answer. Now what we do is this 7 hasn't been used. So we've got to use it because it's part of the number that we were given. So the next thing you do is you say 8 into 73. And 8 into 73 will go 9 times. So because we've gone down now to the hundreds column, we put the 9 in the hundreds column of the answer. But 8 times 9 only uses up 72 out of our 73. So we say, okay, that uses up 72, and we have 1 remainder. And to continue dividing, we now use the next digit, which is the 5. So we say, how many 8s will go into 15? And only 1 8 will. So in the tens column of the answer, there'll be a 1. But that 1 8 only uses up 8 out of 15, and there is a remainder of 7. So just as we drop down the 5 to make 15, we now drop down the 6 to make 76. So now the question is, how many 8s go into 76? And the answer is 9. So in the units column, we write a 9. 8 9s are 72. So we haven't used up the whole 76, we've only used up 72. So we've got 4 left over, or remainder. So when you use this method, which is long division, unless the 8, as in this case, divides exactly after you've used the units column, you're going to have a remainder, and you'd write it as 919 remainder 4. So you can do that. But I don't recommend this method. One, because it takes up too much space, there's too much writing to do, so too much time. And it's inefficient. And also, it's just slightly awkward when you want the answer not to have a remainder, but to give the answer as a decimal. So much better than this is short division. Now I'll do the same division, but using short division rather than long division. The layout is exactly the same. 7, 3, 5, 6. Put the roof over the first number. I'm extending the roof for a reason, which is that I want to get decimals. And then the 8 in front of the roof, exactly as before, except I've dropped it down. Now, there are a couple of important points about the way I have written this, which I'll point out to you. One is that I've spaced the digits out. You must do that. You must not bunch them up. The reason I've spaced them out is so that I can put remainders between the digits without it being too bunched up. Second thing I've done is I've dropped the 8 a little bit, so it's not on a level if you compare it with that one. And again, I'll show you why. So now let's do it as short division. We're doing all the same work, but it's just more efficient. So we say divide into 7,356, 1 column at a time. 8s into 7 will go 0 times. So we put a 0 in that column in the answer. This 7 has not been used, and therefore it's a remainder. We put it in front of the next digit. But what we do to distinguish it from the original number is we write it a bit smaller and a bit higher, so we know that it's a remainder and not part of the original number. Now we carry on. We say 8 into 73, which of course is 9. But 8 9s only use up 72 of the 73, so there's a remainder of 1. And the remainder always goes in front of the next digit, making this 5 into 15. Then 8 goes into 15 once. So there's a 1 in the tens column of the answer. But the 1 8 only uses up 8 of these 15, and therefore there is a remainder of 7. The remainder always goes in front of the next digit, so it goes here, making a 76. Then 8 goes into 76 9 times. 8 nines only use up 72 of the 76, and there's a remainder of 4. Now, you could write it as remainder 4 as I did here, but I'm not going to, because what you should do for 11 plus purposes is continue dividing. You should be able to do that. Obviously, writing remainder 4 is easy. It doesn't require any more work. But to get the answer as a decimal does require more work. Now, that more work is not difficult. It's very easy. We continue to do the same thing. Well, let's do that. The remainder was 4. And as I've said a couple of times already, the remainder always goes in front of the next digit. Well, it appears we've run out of digits. That's not difficult to overcome, because there's an empty column after the 6. An empty column means it's a naught. So there is no reason why I can't write noughts in empty columns. You can always do that. We only write them when they're necessary. We only write noughts when they're necessary. Well, because we want to continue dividing and we have a remainder after we've used up our last digit, the 6, we now need the naught. So we write it. So here it is. Now I have somewhere to write my remainder 4. But I also have a problem, which is that the number I'm now dividing by 8 is no longer the same number I started with. It's now 10 times bigger than it previously was, because the number should be 7,356. But by writing a naught on the end, I've turned it into 73,560. I'm sure you know that the answer for overcoming this is very simple. You'll remember that the next thing that you write after the units column is always the decimal point. So now that I've written the decimal point in, I have not changed this number. All I've done is I've shown that the tenths column is empty. So I haven't changed the number. But now what happens is I have a digit in front of which I can write my remainder 4. So just to remind you, 9 eighths use up only 72 of my 76, and there's a remainder 4. The remainder always goes in front of the next digit. So the remainder 4 goes in front of this naught. Then it's 8 into 40, which of course goes 5 times. So you write the 5. But again, remembering that this is the units column and this is the tenths column, and they must be separated by the decimal point. So in other words, the decimal point in the answer must be in line with the decimal point in the given number. Now, 5 eighths use up the whole of this 40, so there is no remainder, and therefore we finished and we have the exact answer. And the exact answer is 919.5. 919.5. And obviously, when you write the answer, you don't write this 0, because, as I mentioned before, you only write zeros that are necessary. If the thousands column is empty, we don't need to say so unless we had other digits to the left of it. So the answer is simply 919.5.